All right, we're going to talk today. I want to do a few small short talks just on the basics of EKG because I think that was part of the problem that we really never got a chance to go over that. So the first thing I realized is just looking at the paper, what does it mean? Why are there lines on it? So remember, there's an x-axis, which is the horizontal axis, which is time, and there's a y-axis, which is voltage. Now we don't really speak in the terms of voltage or point millivolts. We talk in the terms of millimeters above or below baseline, and we'll talk about that when I talk about ischemia and ST changes in a subsequent little video. But in terms of the horizontal axis, we have little boxes, which are 0.04 seconds. There's 5 little boxes, make up one large box, which is 0.2 seconds. And we know that because that's the way the paper's designed, and we know that the thing is running at 25 meters per second. So that's how we know what each small box. So 0.04 seconds is a small box. 5 of them together make a large box. That's 0.2 seconds, right? So if you had 5 large boxes make 1 second. Okay. 15 large boxes make 3 seconds. And 30 large boxes make 6 seconds. And that 6 seconds is important because that's one of the techniques you'll learn how you can determine the heart rate on an EKG. If you know that 6 boxes is, 30 boxes is 6 seconds, okay? So let me get back to this a second here. And looking at the EKG now, you might have noticed these little chip marks here and here and here, okay? And you can see one here and there. Those typically on normal EKGs are 3-second tick marks, okay? So once again, if I know that's 3 seconds and to here's 3 seconds and I come down to the rhythm strip, I know that the number of beats contained between this check mark and this check mark, that's 6 seconds. Those beats occurred in 6 seconds. If I count those and times it by 10, I can get a heart rate. So let's try that. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, we'll say almost 10. Okay, let's just call it 10. Okay, so 10 of those times 10, I would have a heart rate of around 100 if that was accurate. Okay, because this is occurring in 3 seconds and 6 seconds. So 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is about a rate of 100. Okay, so not 100% accurate, but that's one technique we can use. The other technique I talked to you about is how we can do all of the, just find one that's on a big strip or a big line right here. And we just know because of the way, once again, this goes, the next line over would be 300, the next line over would be 150, the next line over would be 100, the next line over would be 75, 60, 50. Okay, so if this beat was here and the next beat was here, my heart rate would be 50. If it was here, it'd be 300. So here we have 300, 150. I'm not at 100, but I'm not at 150. I'm about 2 or 3 small boxes, right, between 150 and 100. If there's 5 small boxes between 50 and 100, each small box is 10. So if I go from here 100, 110, 120, 130. So that technique, I would have a heart rate of about 130, which is actually, when I printed this from the machine I have, I think I set it at 130. So that's pretty accurate. Now when you do this other technique, as I mentioned, it didn't quite work out. So why is that? Well, let's just count all the boxes, right? So once again, if I said that there's 30 boxes is 6 seconds. So let's start here. 1 box, 2 box, 3 box, 4 box. Let's start over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 boxes. Okay? And in between I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I had 12 um, beats in that period of 6 seconds, okay, times that by 10, I get a rate of 120, okay? So once again, as I said, the faster you are, you're going to be a little less accurate because you can't really figure out exactly where it is, and you know, you're not, depending where you started, there might be a little gap here where the next beat would have come, but I'm pretty close, okay? So I know that's still a little bit confusing. There's a very good explanation of it in the book, which is here. So here is the one technique I mentioned with the 300, 150, 100, 75, 60, 50. And if you go a little more below 50, it's actually get down to 43, okay? And that's one of the easiest ways, okay? And then if you wanted to do the other technique, here's the 3-second marks, 3-second mark, and here would be 6 seconds, like we just counted out 30 boxes. We did it the hard way. And we had 1, 2, 3, 4, 5, 6, 7 times 10 would be 70. Now let's see if the other one, that's accurate. If we got 70 by using the 6 seconds, counting the number and times it by 10, here if we take 300, 150, 300, 150, 100, 75, and 60, and between 75 and 60, they're each a 3. There's 5 boxes. There's 15 total difference between 60 and 75. So each box is 3. So if this is 60, 63, 66. Okay, so we'd have 66 versus the other technique was 1, 2, 3, 4, 5, 6, 7 times 10 was 70. But once again, if this was off the paper a little or we'd started a little sooner, we could be 60. So 66, 70, we're pretty close. Okay, so those are the two techniques that we are going to use mostly for looking at the rate, okay? And we usually use the R waves. Now, just once again, as we get more sophisticated and start learning about things like heart block, you also can get a P wave rate and a QRS rate. They should be 1-to-1 in normal sinus. If they're not, and you're using your calipers and the P waves, you got a lot more P waves than QRSs, that would be abnormal. And we'll talk about that in the future. Okay, so just remember those boxes, and the next we're going to talk about intervals real quick. Okay, we'll keep it going. So the intervals, once again, here is the PR intervals from the very start of the P wave to the start of the QRS complex. The first down wave is the Q wave. A lot of times you'll notice some leads there is no Q wave. The first upstroke is the R wave, and the stroke coming down below the baseline is the S wave. So we call that the QRS complex. The PR interval is between the start of the P wave and the start of the Q wave, or QRS interval. Okay? The QRS complex is the start of the Q wave to the end of the S wave, before the ST segment starts. Okay? And then the QT interval is actually includes the QRS because it's the start of the Q wave, the end of the PR interval, starts the QT interval, all the way to the end of the T wave. Okay, and those are the 3 intervals. And once again, by measuring these boxes, we know these are all 0.04. So using your calipers, you can put a point here, and then just compare it to that and get a rough estimate of its size. Now before we finish this, I'll show you how I did that here. So here is the PR interval. Pen's going to mark a little big, but here's the start of the P wave, the start of the QRS complex. I used my calipers, measured that. I came down there to check it in a clean area so I could see the little boxes. And I ended up with about 3 little boxes, which is 0.12 normal PR interval. The QRS, when it's very narrow, can be really difficult to get an accurate measurement. It doesn't matter if it's super narrow. What we're more concerned is when it's long. But I measured the Q wave, the beginning, end of the S wave before the ST segment, and I got about 1.5-ish small boxes, so 0.06 milliseconds. And then for the QT, start of the Q wave, end of the T, it was actually pretty short, because then I came down and measured it here, and I got somewhere around 0.3, 0.26, but remember, the faster the heart rate, and this was tachycardic here, the shorter the QT interval will become normally. The slower the heart rate, the longer the QT up to a point. And so when you get a printout from the EKG, you'll see up on the top, it'll say QT, it'll say QTC. The QTC is corrected by the machine for the heart rate. And we're generally in that 0.36 to 0.46 range, kind of ish, is sort of normal. It's calculated basically, the non-corrected is what it would be at a heart rate of 60. That's what we correct for. What would it be at a heart rate of 60? So if you're 120, it'll correct it, tell you this is the corrected QT as if your heart rate was 60, which is our standard. Okay? All right, end of that talk. Thank you.